Hello, everyone. This is going to be a review of this week's material. So if we actually look, the stuff that we did was we did events, and we also did collision resolution. So that is what we will be going over today, and kind of how that stuff works. We will also be looking at these. So first, going with events. Basically, what kind of happens is we are going to be doing a couple things. Right now, we are doing hard coupling of data communication. This is done through things like GameObject.find, and also getComponent is another one that happens a lot. So there's a lot of stuff where it's direct communication, but what we want to do is we want to do loose communication where basically we say something happens and then the people who need to know that happens get it and act upon it individually. And we do this by using events. What we do is we register listeners for events, and these listeners are the ones that we can even just do this. And what happens is that these are the ones that listen for events. So, for example, inside of start, on this test event system, we have a register listen for button 1. That means that when we send event.handle event button 1, that means that this controller will get called and this handle event will be called. Now, we're not directly communicating from one game object to another. We're sending it to someone, the events class, that will manage who gets what now. So that's what we mean by loosely based coupling. Another example would be with button 2, where now this controller component listens for both button 1 and button 2 activities. And what we do is we just do it. We register events, and then whenever those events happen, we call the handle event. And the way we send those events out is with events.handle events when it is on mouse button as up and on mouse up as button. So that's the main thing that that we do with loosely based coupling of events. The next one though is collisions. Not collisions, but events based off of collisions. And this is where we get a little bit more. First, before we do that, let's explain what fixed update does, and then we'll do physics stuff. So right now, what we do is we move the mouse, or the way we do it is we do on mouse trigger, enter your mouse events. Then we do your collision resolution events. Then we update, then we destroy, and then we draw. What happens though is that we do update after our collision triggers. So what could happen is we're not in collision, then when we call update, then we become collision, and then we draw that collision. And we don't really want that to happen. So the way we get around this is through fixed update. Fixed update is done before collisions and mouse and inputs are done. So that what happens is, say we are in collision inside a fixed update, or when we have to update our movement, and then we'll know if we're in collision or not for a collision resolution and like triggers and stuff. So that's kind of the reason behind fixed update. And my other video this week kind of explains one possibility where we have a move action component. And when you move, instead of calling update, we just now call fixed update because we want the movement to happen before we trigger collision resolutions and collision events. Now, So now that we know kind of fixed update now, let's go through kind of our physics and stuff like that. Let me do this. Okay, so now we're doing collisions, and we can look at this example. Or not collisions, but inside a scene. Obviously, we've done on mouse over events and that stuff, but now we need to do collisions with respect to what each one does. And let's go over the image first to make sure we know. There's kind of 4 types. So there's coins. So for example, imagine a coin-on-coin collision. Say you're playing Mario, and you send, or there's a coin that's moving, and it interacts with another coin. We don't want it to initiate events because there's no real. I should rephrase this. We only initiate events if a rigid body is involved. That's kind of the whole key purpose of it. So, for example, say you have a wall and you have a coin. That wall should not have a rigid body, but it still needs to reflect with collisions. So what happens is if you have a coin, you don't push back against the character or other coins. You have no rigid body because you don't really want physics on it. And is trigger is true, and this means you don't instantiate events. So when it is a is trigger, so if both of the collisions that happen are triggers, then you call trigger. If at least one of them is a trigger, you call trigger. If both of them are not triggers, then you call on collision. The main time you call on collision is when 2 rigid bodies interact with each other. But it's not a hard rule. With the floor and the elevator, it pushes you back, but it doesn't get pushed. So you don't initiate events. There's no events to initiate, and this is because there's no rigid body on it, and is trigger is false. With sensors, rigid body is true, or there is a rigid body and there is a trigger, and you don't get pushed back, and the other entity doesn't get pushed back, but it does initiate events. So say, for example, you have like say you're walking and you step on a pressure plate or something, and something is supposed to happen when you touch the spot. This is what the sensor would be. And then normals and characters, they push back and they get pushed upon. There's rigid body, is trigger is false, and they do initiate events. I would highly recommend you understand this and even just code some very, very basic examples of this and even look at the game that was provided. And the game would be the test. I think it would be this one. Oh, let's see why. More tools, developer tools. Does this not have a rigid body? Nope, it doesn't. Then I will just do this. JS. Huh. No, it does have a rigid body. Wonder why it isn't. But, so, but let's go through our scene and go through kind of what is happening with what. So first we set active collisions to be an empty list every single frame. We loop through both the collidables, and we see if neither of them have a rigid body, then we just continue because we don't care. We only care if at least one entity has a rigid body. Otherwise, we continue. If at least one of them has a rigid body, we get the result. And if the result is false, then that means they're not in collision. Then we go on. Then we do this constant collision variable where we create a dictionary where either one maps to one, two maps to one, a result, or we have to flip it and say one maps to two maps to one, result is then a result times -1. But either way, we get some sort of collision dictionary or object, and we push it onto active collisions. For every active collision, we assume it's on trigger. If both of them have a collider and is trigger is false, that means that it's on collision. And we can go back to the image. If both is trigger is false, that means it's on collision, and is trigger is false primarily on characters and floors and events. So say you have a wall. That wall would not have a rigid body, and your character would be able to interact with that wall because it has a rigid body. Since both of them are false, it will trigger on collision. So if both of them have is trigger is false, then the actual type is on collision. Then if we say last frame, so if the last frame has some sort of pair where the pair of 1 equals collision of 1 and the pair of 2 equals the collision of 2, that means that we are currently still in collision, and that means we do on collision or on trigger stay. This will be explained in class on Monday, I assume. We forgot to do one little thing with that. Otherwise, if the previous frame of collisions doesn't exist, then we broadcast it as on collision enter or on trigger enter. If the type equals on collision, that means that both of them have is trigger to be false, but both of them are some sort of floor or air character or elevator. What happens now is we get the rigid body of both of them. If both of them have a rigid body, what that means is they're both normals to characters, and then both of them get pushed back upon each other. That means that when we do this, we have to adjust the 1 of times 5, 2 by the result by 0.5 as well, so that we split the difference between moving one and the other, so both of them are affected by each other. This only happens when a character or a normal interacts with another character or normal. Otherwise, if one of them has a rigid body, if the first one has a rigid body, then we update the position to be of the result times 1. Otherwise, it is just the result times -1. Now we, just like we did for mouse input, we loop through the last frame, and we do the same logic of type equals on collision or trigger. And if we're not in the current one, then we do exit, and then we update this last frame collisions. So for example, one good thing to kind of do the study for this stuff is just look at a pre-existing game. So like we did in class. So let's do, I don't even know what would be a good game for that. I know off the top of my head. Let's do Binding of Isaac. That's one of my favorite games. So you see, you have Then let's pull the image up. So we have coins, floor, elevator, sensor, and normal characters. Obviously, the characters itself. So you have this player and you have that player. And you see that, or let's do this one since there's a little bit more environment and stuff. So you have characters existing. And with those characters, they would have a collider, or from the here, they would have a rigid body and a collider, and they would have is trigger is false because they are in they interact with the environment, and they do initiate events. So if they run into an enemy, an event could be called to then take some sort of damage. They do get pushed back or at least interact with the environment as well. Sensors is a little bit more general. Probably kind of hard to see a sensor in an image, but one thing you could maybe do is maybe if you hit or you go over a area, something happens, or if you walk into an enemy, for example, they might not get hit and pushed back, but something does happen. So say there's like a force field around someone and you try and hit it, and it just prevents you from moving forward, like an invisible barrier in a game, for example. Obviously, the floor or elevator type idea is like the wall in the game, and the coins. There really isn't no coins, but there are coins in the game. So there's coins in the game like these, and this would be something where coins would happen. Just I would go through games, and if you were struggling to actually identify, then I would 100% go through and just label stuff, because that this is very, very important for this course, especially if you go into Unity advanced game programming, where we dive into Unity. And then the final image that we have is this one right here. And that's basically saying that sometimes if your collisions aren't working, specifically for like a specific wall or with a specific character, you can actually just skip collisions entirely by jumping over the wall. So you check collisions your previous frame, which is this one. In the next frame, you're over here clearing the wall. That means that you just skipped the wall entirely and therefore no collisions occurred. There's a couple ways to do this. If you just connect the previous and current frame, and then you do collisions on that, that would work. There's also a couple other alternatives that if something really needs to occur, then we can talk about it. But that is pretty much it. I would also highly recommend you just look at games and look how that and just make stuff that deals with collisions as well, because the best experience is practice. I hope this kind of helped clarify some things. If you have any questions or comments, you can always email me or Rix, Professor Rix. Otherwise, yeah.